Parallelogram law of vector addition. If two vectors, vector A and vector B, are represented by the two adjacent sides of a parallelogram in magnitude and direction, then the sum, vector A plus vector B, is represented in magnitude and direction by the diagonal of the parallelogram through their common point. This is parallelogram law of vector addition. See what is happening here. This is the first vector A, second vector B. Both of these vectors are represented by the two adjacent sides of this parallelogram ABCD. So this parallelogram law of vector addition says that the sum or the resultant of these two vectors is represented by the diagonal of the parallelogram through the common point. Let's move on to the property. Vector addition is commutative. A plus B equals B plus A. Then we will get a clear idea about the parallelogram law of vector addition also from here. See, we shifted this vector B to that side. Parallelly, we shifted this vector B to that side. There is no change in its direction as well as in magnitude because they are the opposite sides of a parallelogram. Now we are getting the advantage that the initial point of this vector and the terminal point of this vector are coincided here. Therefore, we can add this A and B. Therefore, this is the sum of those vectors A plus B. Therefore, see once again, A and B are added. Therefore, it is A plus B. In the same way, we can shift this vector B A to this side because they are opposite sides of a parallelogram. So let's move A to that side. Then we are getting the advantage here also. The initial point of this vector A and the terminal point of this vector B are coincided here. Therefore, through this we can add this B and A. Therefore, this is B plus A. This is same diagonal is B plus A. So here, see, this is B plus A. In one way it is B plus A, on the other way it is A plus B. Therefore, both A plus B and B plus A are same. And one note also is there. Vector A plus 0 vector equals 0 vector plus vector A, that is equal to vector A itself. Therefore, 0 vector is the additive identity of vector addition. So let's move on to the next property. Vector addition is associative. That is A plus B plus C equals A plus B plus C. See, first vector A, second vector B, and we are going to add the first and second vector, that is this plus B. With the sum, we have to consider or add the third vector C. Therefore, this is A plus B, this is C. Therefore, A plus B plus C is equal to AD. See, this is AD is A plus B plus C. A plus B plus C is equal to AD. This is one case. So in the another case, first of all, we consider the second vector and third vector, and we are adding those two vectors. This is B, this is a C, this is B plus C. Through this B and this is B plus C. And with this B plus C, we have to add A. Therefore, consider A. This is A plus B plus C is AD. A plus B plus C is equal to AD. Therefore, in this case, AD also is equals A plus B plus C. So, A plus B plus C is equal to AD, and A plus B plus C also is equal to AD. Therefore, from these two statements, we can say that A plus B plus C equals A plus B plus C.